Oh, we have another speaker from Indonesia, Moondra Zubir from Universiti Negeri, Medan, Indonesia. I visited Medan 2019, and he's going to talk magnetic field effect on porous coordination polymers synthesis and absorption properties. Dr. Zubir, welcome.
Good morning all. Welcome to SLI International webinar on the role of nanotechnology in current scenario. So I'm Moondra Zubir from Department of Chemistry, Faculty of Mathematics and Natural Science, Universitas Negeri Medan, North Sumatra, Indonesia. So today I would like to talk about the magnetic field effect on porous coordination polymers or PCP synthesis and their adsorption properties. This is the outline of my presentation. I'd like to share how magnetic field control of the micropore formation on this PCP, zinc to oxide TAZ2 water. It's including the structure, properties, and its carbon dioxide absorptivity. And then also I compare with the similar PCPs, we change the TAZ ligand to ATAZ to form the zinc to oxide ATAZ2 water, and also observe how the magnetic field effect on crystal structures and pore properties. Besides the inorganic materials or zeolite and carbon materials, now recently the new porous material is formed as coordination polymers, or as well known as the porous coordination polymers or PCPs, or metal organic frameworks or MOFs. So these porous coordination polymers was synthesis by self-assembly from the metal ions and organic ligands to form the one-dimensional, two-dimensional, or three-dimensional PCPs. These two-dimensional and three-dimensional PCPs usually formed by choose the two kinds of organic ligands during the synthesis. So these porous coordination polymers or PCP have some classified. First is the rigid framework. This is the two examples of rigid framework PCPs are MIL100 and MIL127, which include the Fe and Cr as the metal ions. But these rigid frameworks have the properties are stable and robust porous framework with permanent porosity. And usually this PCP present a normal type 1 of the adsorption isotherm. The second PCP is the flexible or dynamic frameworks. This flexible or dynamic framework PCP have the extreme change of set when the gas molecules are inserted or removed, and they also affected by external stimuli like the change of the temperature of the pressure. This is the one example, the famous example of the flexible or dynamic framework of PCP is pre-ALM11. So this pre-ALM11, initially by carbon dioxide absorption, no carbon dioxide absorbed in initial stage. But then after the higher the pressure, then they have the hysteretic absorption or also the hysteretic desorption. So this is the one of the properties of this flexible dynamic framework. They have excited the stepwise absorption for the hysteretic absorption. The second PCPs is the open metal site PCPs. These open metal sites can enhance the gas absorption after the metal ion they open the metal side of the PCPs. The fourth of PCPs is the surface functionalized framework. The surface functionalized framework contains the gas interaction site as the functional group, such as the amine or hydroxyl group. It can enhance the capacity and the selectivity for gas adsorption, especially for carbon dioxide. So interaction between the functional group and the carbon dioxide gas can enhance the selectivity, the absorptivity of carbon dioxide. And beside the catalyst or biosensor, so I use this application of PCP as the gas storage. So in this experiment, we do for the nitrogen absorption for four properties observed, and then the carbon dioxide absorption. And how magnetic field effect during the synthesis, and also including the adsorption properties. So if we synthesis the PCPs at 0 Tesla or no magnetic field, so the crystal drops disorder. Besides that, if we prepare in magnetic field, the crystal drops slowly and form the order crystal structure. And previously in Shinshu University, Japan, at 2008, they successful to prepare the one of PCP, CU, PZDC, PYZ. And when the prepare at 0 Tesla, this PCP form as 5 coordination number of PCP and then change to 6 coordination numbers when the prepare at magnetic field 6 Tesla. So in this experiment, I observe how the magnetic field control of the micropore formation of the zinc oxide TAZ water. So this in this first PCP, we use TAZ with the water and also the water solvent. So the magnetic field will observe how the effect in structure, properties, and also the absorption. This is the experimental stage of this research. This is material used for metal ion zinc. We use from zinc carbonate basic, and then the two ligand choose for this synthesis. First is 1,2,4 triazole for triazole ligand, and then oxalic acid for the second ligand. And then we use the methanol and this distilled water as a solvent during the synthesis. And this is the PCP synthesis stage. So all zinc, metal ion, oxalic acid, and triazole mixture of 12 milliliter methanol and 2 milliliter water, and heat it at 453 Kelvin for 12 hours in autoclave system. After 12 hours, cooling the system to room temperature, and then filter the crystal form. And for purification, washing with the methanol and water, and then the final stage, dry at room temperature. And in this PCP, we characterize by XRD, sand, and also the four properties observed by nitrogen absorption isotherms at 77 Kelvin, and then carbon dioxide CO2 absorption isotherms at 303 Kelvin. This is the PCP synthesis design outside the magnetic field. So no magnetic field used in this for synthesis. So this all the metal ion first and the second ligand mixture in this sample vessel with vessel cap, and then insert to autoclave system and stay for 12 hours. And this is the PCP synthesis inside the magnetic field. So the previously slide is the synthesis outside the magnetic field, considered as 0 Tesla, and in this magnetic field, this autoclave system insert to magnetic field and then set the magnetic field as 2 Tesla 4 Tesla, and 6 Tesla. And this is adsorption isotherm measurement. We use the volumetric adsorption isotherm apparatus, and before the adsorption isotherm measurement, based on the PGDTA analysis, the solvent was removed around the 110 degrees Celsius. So before the adsorption measurement, we do the pre-treatment temperature in 2 stages. Initial stage at this 333 Kelvin for 1 hour, and then continue at 383 Kelvin for 12 hours. And then after pre-treatment temperature, the adsorption measurement for nitrogen and carbon dioxide, nitrogen adsorption at 77 Kelvin, and then carbon dioxide at 303 Kelvin. So this is the XRD pattern and the crystal structure of zinc oxide TAZ prepared under various magnetic fields. And if compare this 1 Tesla, 0 Tesla, 2 Tesla, 4 and 6 Tesla, if we source from these XRD patterns, it looks like not significant difference between the 0 Tesla and 6 Tesla XRD patterns. But for 2 Tesla and 4 Tesla, it looks like slightly change of the XRD pattern, especially for the highest peak at this 0 Tesla. It considers that the lower the 6 Tesla magnetic field, the significant change of XRD, the structure was performed when they prepared under magnetic field. And by this is the zinc 2 oxide TAZ to water crystal structure. This shows that the metal ion, zinc metal ion, bind with the triazole ligand and oxalic acid ligand and form 5 coordination number of PCPs. Okay, this is the some observation from the XRD patterns, which we saw that the 2 Tesla and 4 Tesla have the sum of the intensity change in sum of 2 Tesla at 2 theta position. So this peak intensity change then performed by using the Expo 2015 analysis, and we get that the 0 Tesla, even 0 Tesla and 6 Tesla crystal, not significant XRD patterns, but the crystal system changed from monoclinic to triclinic crystal. And interestingly, the 2 Tesla and 4 Tesla with significant change of the XRD pattern, it looks like a slightly same 2 Tesla with 0 Tesla and 4 Tesla with 6 Tesla. It suggests that when 0 Tesla changed to 6 Tesla, 2 Tesla and 4 Tesla looks like the intermediate phase before change from monoclinic to triclinic. And this is the same image for all magnetic field crystal. You can see the morphology of crystal change from 0 Tesla, 2 Tesla, 4 Tesla, and 6 Tesla. Even though the 2 Tesla and 4 Tesla, it looks like similar morphology. And but 0 Tesla and 6 Tesla, it looks like the significant change of the morphology. It's supported by the XRD pattern that 2 Tesla and 4 Tesla have the same intensity change for XRD patterns, also induce the slightly change of the morphology before change from 0 Tesla to 6 Tesla. So this is the 1 Tesla and 6 Tesla comparison with for same image. And you can see the 0 Tesla crystal form as this order crystal change to rectangular shape of the 6 Tesla crystal, and also the smoothly surface of the crystal. So to investigate the core properties of these PCPs, we observe by nitrogen adsorption isotherms for 0 Tesla and 6 Tesla. And this is the temperature or pretreatment temperature before the adsorption. So we measure without the pretreatment temperature, and also with 3 hours, 6 hours, and 12 hours pretreatment time. And for 0 Tesla, when the pretreatment, no pretreatment time and only 3 hours, the pretreatment temperature, it's the pore not yet formed. If compared with 6 Tesla, without the pretreatment temperature and also 6 hours and 12 hours, the pore already formed for this magnetic field crystal. Now, if compared by the other magnetic field, it's shown also the same phenomena for magnetic field crystal. It's the 4 Tesla without the pretreatment temperature already formed the pore of the crystal. So we consider that this magnetic field crystal, especially for 4 Tesla and 6 Tesla, have the form as hydrophobic type of frameworks, because without pretreatment temperature, the pore formation already occurred in this crystal. If compared with the 0 Tesla without pretreatment temperature, in this 0 Tesla crystal, should we remove the solvent first to form the framework of PCPs. And the second phenomena, we observe that this rectangular shape of the type 1 of isothermal adsorption is considered as the homogeneous pore. So to prove this hypothesis, we do the solvent loss measurement by gravimetric method, and this initial stage, the first stage, it's only vacuum pump at the 298 Kelvin for 10 minutes. So only by vacuum pump for the 298 Kelvin for 10 minutes for all magnetic field crystal can remove the solvent if compared with 0 Tesla. The 0 Tesla, after 5 and 4 hours, the solvent gradually decrease or remove from the crystal. So we consider that this magnetic field crystal form as hydrophobic type of framework. And to investigate the pore properties of this magnetic crystal and without the magnetic field crystal, so pore volume crystal observed by various pretreatment time and various magnetic field. And you can see the 0 Tesla crystal have the pore volume after 3 hours, but the magnetic field crystal, all 2 Tesla, 4 Tesla, and 6 Tesla, already form the porosity without the pretreatment temperature need. And then if you compare the magnetic field, this magnetic field 2 Tesla and 4 Tesla have also the specified the pore volume if compared with 0 Tesla and 6 Tesla. So it's considered it's supported by the XRD pattern intensity change before for 2 Tesla and 4 Tesla crystal. And then this is the carbon dioxide adsorption isotherm of zinc oxide TiZ. And we can check the 0 Tesla, 4 Tesla, and 6 Tesla crystal with pretreatment temperature for 12 hours and no pretreatment temperature. This is the synthesized crystal. But the 0 Tesla, it cannot absorb this carbon dioxide when the adsorption isotherm without use the pretreatment temperature. But the 4 Tesla is slightly amount of carbon dioxide absorbed without pretreatment temperature. But the interestingly, for 6 Tesla, already absorb the CO2 even no pretreatment temperature. Then after 12-hour pretreatment temperature, the 6 Tesla also absorb the highest carbon dioxide if compared with 0 Tesla and 4 Tesla. And then the second similar PCP also synthesis as zinc oxide ATAZ. So I changed the TAZ ligand to ATAZ and also observe how the magnetic field effects on crystal structures and pore properties. So this is the strategy why I changed the second ligand from TAZ and to ATAZ, because the gas storage capacity in PCPs can be enhanced in various ways, such as first, we can increasing the surface area. The surface area increasing based on the size of gas will absorb inside the framework of PCPs. But the second strategy is functionalizing organic income. So some paper was reported that the amine group can enhance this carbon dioxide absorption. So in this triazole ligand, we inserted the amine group as the gas interaction site with the carbon dioxide to increase this carbon dioxide absorption. Okay, in this study, we changed the amino triazole become 3-amino-1,2,4 triazole, and then also we use the same first ligand is oxalic acid. For crystal structure of zinc 2 oxide ATAZ and zinc 2 oxide TAZ, it's formed as the similar PCPs, so not significant different. Or zinc, both of these PCP form as 5 coordination number of PCP with zinc metal ion bind with the 3 triazole and 2 oxalic acid. But if we observe the framework of pore properties of these two kind of PCPs, for zinc TAZ, if the pore framework will not contain the functional group, but in this zinc oxide ATAZ, inside the framework, they contain the amine group. The amine group inside in the pore. So its possibility will help to capture the carbon dioxide because the strong van der Waals interaction between the carbon dioxide with the amine group. And this is the experimental steps for the second PCPs. Also, we use the same metal ion zinc carbonate basic, and then 3-amino triazoles first ligand, oxalic acid the second ligand, and 2 with the methanol and distilled water for the solvent. Also, the characterization performed by XRD, SEM, and nitrogen absorption isotones for pore properties. And this is the PCP synthesis, also the same stage between PAZ and ATAZ ligand. So all the metal ion and ligand mixture of 12 milliliter methanol and 2 milliliter water, and then heat it at 180 degrees for 12 hours in autoclave, and then cooling to after 12 hours cooling to room temperature, and then the filter crystal form washing with the methanol and water, and dry at room temperature for 1 day, and then we do the characterization. The characterization by XRD and also the pore properties observed by nitrogen and carbon dioxide absorption. And the same also, this is PCP synthesis under magnetic field. Also, we measure at the one we synthesize at 0 Tesla, 2 Tesla, 4 Tesla, and also 6 Tesla. And this is the XRD patterns of zinc oxide ATAZ under magnetic field. And similar with zinc oxide TAZ, between the 0 Tesla and 6 Tesla, it looks like not significant difference. So we consider these two kinds of PCP, thiazide and athiazide ligand, have the serious effect on the structure by magnetic field at long magnetic field, or 2 Tesla and 4 Tesla, lower than 6 Tesla, because the 6 Tesla magnetic field crystal not significant different with 0 Tesla. Even though, even the highest intensity for 6 Tesla higher than 0 Tesla. And the difference of this second PCPs, if compared with thiazide, if thiazide changed from monoclinic to triclinic, and this PCPs 0 Tesla and 6 Tesla form as the same crystal system, or is orthomic, but the 2 Tesla and 4 Tesla with significant change of the intensity of exadependence change to triclinic system. And if compared the same image of this zinc oxide athiazide, the presence of amine group induces the interesting morphology for its magnetic field crystal. For zero, this is the 0 Tesla magnetic field morphology, and then change to 2 Tesla. It looks like the particle size is increased than to 0 Tesla. And then 4 Tesla crystal with significant change for exadependence also have the significant image change of morphology. So and then 6 Tesla, it looks like make a cubic shape if compared with the 4 Tesla as the rectangular shape. And this is the adsorption isotherm measurement, the same system used for this adsorption isotherm with the previously PCP. We use the volumetric adsorption isotherm parameters, and also we do the pre-treatment temperature with the same stage, initial stage at 333 Kelvin for 1 hour, and then continue to 383 Kelvin for 12 hours. And also nitrogen adsorption will be measured at 77 Kelvin, and carbon dioxide at 303 Kelvin. And this is the nitrogen absorption isotherm of zinc oxide athiazide. So it's on all 0 Tesla and magnetic field crystal cannot absorb the nitrogen gas. It suggests that pore formation is disturbing by the presence of amine group inside the pore. But interestingly, for CO2 absorption, the interaction between CO2 and amine group induces the significant amount of carbon dioxide captured in the frameworks. So this is the left side for 0 hours pre-treatment time, no pre-treatment time, and this is pre-treatment time at 110 for 12 hours. And 0 Tesla and 6 Tesla that have the same exadependence cannot absorb the carbon dioxide at the low pressure below the 400 torr. But after 400 torr, it's significant increase for the CO2 absorption amount. But especially for 2 Tesla and 4 Tesla, which change the exadependence, they can absorb the carbon dioxide with significant amount. It considered that the interaction of the CO2 and amine group increase in this 2 Tesla and 4 Tesla magnetic field. And then for after pre-treatment time at the 110 degrees Celsius for 12 hours, only 2 Tesla have the slightly intensity of slightly the amount of the CO2 can absorb. If compared with no pre-treatment, it looks like the structure, the composition or change because by the heat at 110 degrees for 12 hours. Besides that, on the other hand, for 0 Tesla and 6 Tesla, they have the higher CO2 absorption amount, and 6 Tesla can absorb the CO2 absorption highest than 0 Tesla, 2 Tesla, and 4 Tesla. And this is the performance of CO2 absorption isotrams that at low pressure, 350 torr, and then 760 torrs. So if you compare it 2 Tesla and 4 Tesla at low pressure, they induce the strong interaction at low pressure around the 350 torr. But after increasing the pressure to 760, for 2 Tesla, it look like have the decomposition of structure because the presence of amine group. So the absorption of carbon dioxide is lower than the other crystal. But for 6 Tesla, by high pressure, have the strong interaction between the carbon dioxide and amine. And this is we try to make the zinc oxide HZ core model people under magnetic field. So we consider based on the CO2 absorption and also the characterization data from XRD and same image. So this is the model of zinc oxide APZ for 0 Tesla and 6 Tesla. So the amine group interaction between the amine group and the carbon dioxide, it looks like 0 Tesla and 6 Tesla have the wide pore space and the rigid structure stability. But for 2 Tesla and 4 Tesla, the pore space looks like narrow, and 4 Tesla may be very narrow if we observe from the absorption data. And we consider this 2 Tesla and 4 Tesla crystal form as the flexible structure stability. Okay, then this is the conclusion and the outlook of this research, that the zinc oxide APZ and PZ 2 Tesla and 4 Tesla magnetic field solves the new crystal structure for APZ 2 Tesla and 4 Tesla. Even though looks not stable structure observed by X-ray pattern and IR spectra. And then also the APZ 2 Tesla and 4 Tesla solve the significant amount of amine peak related to high of CO2 absorption, even no pretreatment temperature. And also the zinc oxide APZ 2 Tesla and 4 Tesla observe significant change of amine group after 12 hour pretreatment at 110 Celsius. Okay, thank you very much for your kind attention. That's all my presentation, and then maybe we can open for detailed discussion. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.